morning everyone. Today's class we are going to discuss about direct memory access. So before that, we have to know what is memory and what are the types of memory that will be given by Vinaya. So normally the direct memory access, what we are doing here is we are going to speed up the CPU operations. So in order to speed up the CPU operations, we don't want to often disturb the CPU. So for that we are using DMA controller here. So what this DMA controller is doing? It receives the request from I/O devices. What are the I/O devices? You all know? Keyboard, mouse. So these are all the I/O devices. With the respect of I/O devices, you are giving DMA request to the DMA controller. So once the DMA request is received for DMA controller, it gives a request to CPU because we need permission from CPU to take over the bus. Okay. So for that, it uses BR signal, that is bus request signal, will be given to the CPU. So once the bus request signal is received by CPU, CPU will decide whether it can give the bus to the DMA controller or not, based on the operations and based on the schedule. Okay. Once it is decided, it gives the acknowledgement. Now acknowledgement is nothing but bus grant signal. This BG will be given to the DMA controller. So once the BG signal is received by DMA controller, which means the CPU has given the permission to take over the bus. So bus is nothing but a path which is used to take the information from one place to other place. So the main process of transferring the data is from memory to I/O device. So for that we receive now permission from CPU. So now the CPU will give you address and data, where you have to take the data and what data you have to take. That will be given through this bus. The address of the memory will be given through this bus. The data of the bus will be given through this bus. Okay. So the address starting address will be 1000 and ending address will be 1020. So there are 20 memory locations we have here. So 20 instructions we have in the memory. Okay. For example, I am writing a prime or not program. So that will be 20 lines. That will be stored here. So that will be taken one by one and it will be given to the I/O devices. So once the request is received for DMA controller, address and data will be also received. Then through this address, we can take the data from memory. So that will be given to I/O device. Okay. So once the permission from CPU is received for DMA controller, immediately the DMA controller will give the acknowledgement. Okay. So in the communication, you have to give request and you have to get reply. That means acknowledgement. So first the I/O device gives the request, but still the acknowledgement is not received from DMA, which means the I/O device feels that there is no permission given by CPU. Okay, so that what DMA controller will do here is, initially once the permission is received, it gives the acknowledgement to the I/O device. I/O device know that we have to be ready to receive the data from memory. So the acknowledgement will be DMA ACK. The signal name is ACK acknowledgement. Okay, once the acknowledgement is received here. So here there are totally 20 instructions are stored. If the first instruction is transferred from memory to I/O devices, there will be counter. The counter, the 20 number will be saved. Okay. Once the first instruction transferred this bus to I/O device, what is the count here? It will be decreased by 1. Which means 19 instructions are balanced in the memory. Then again second time, another second instruction will be transferred to I/O device. Now the count will be 18. Likewise, the count will be decreased. Once the counter comes to 0, the CPU will monitor this counter. Okay. Once the counter is 0, what the CPU thinks, all the instruction has been transferred completely from memory to I/O device. Okay. So that is what happening here. Okay. So finally, all the operations, everything has been completed. that a complete information from the memory has been transferred to I/O device. So you can transfer in two different ways. In single attempt, you can transfer all the 20 instructions to your I/O device. In single bus, if you transfer all the 20 instructions to I/O device, that is called burst mode. Second one is cycle stealing mode. In cycle stealing mode, one by one instruction will be transferred. For transferring first instruction, you have to give a request to CPU, then you have to get the acknowledgement, and then you have to transfer the first instruction. For second instruction, again you have to give request, then you have to get acknowledgement, you have to transfer. Like that, you have to give a 20 request to CPU, 20 acknowledgement will receive, then 20 instruction will be transferred to I/O device. Okay, so there are two ways you can transfer the data. Once all the instruction is completed, what the final signal will be given by CPU. That is nothing but interrupt signal. So this line, which means once the interrupt signal received from DMA control, which means entire job operation will be completed. Okay, so that's all about your DMA. We are going to transfer the data from memory to I/O device without interrupting your CPU. We are going to get only the permission from CPU. Okay, so this is about all about DMA. Summary will be given by Sadhana.
So we saw about memory. Memory is storage device. Types of memories are primary memory, secondary memory, and cache memory. Primary memory we have RAM. RAM we have DRAM, dynamic RAM, and static RAM. We have cache memory. And in primary memory we have read-only memory. In read-only memory we have PROM, programmable ROM, and EROM, EEPROM, electrical erasable.
What is DMA?
So next we saw about DMA's direct message access. It is an order mechanism used to help I/O device to fetch information from the RAM. We are using CPU. So here we have CPU and the RAM. This is I/O device. This is DMA controller. If I/O device want any information from the RAM, without asking the CPU, it uses DMA control to fetch data from